Our solar system contains over 200 moons, each a world of its own. Some of these distant spheres guard secrets that have left our most brilliant scientists utterly perplexed. We are about to journey to 25 of the most mysterious ones, from volcanic hellscapes constantly erupting with fire to frozen shells hiding vast oceans that might just cradle alien life. By the end of this tour, you will know which of these strange worlds could rewrite our definition of life itself. We will see a moon spraying its hidden ocean directly into space and another that looks like a forgotten battle station. What single mystery do you hope we might finally solve? Our journey begins with a world of fire, Jupiter's moon Io. It is a place of constant, violent rebirth where the very ground you stand on might not be there tomorrow. This is the most volcanically active body in our entire solar system. Hundreds of volcanoes scar its surface, many erupting at any given moment. They spew fountains of molten rock and paint the sky with enormous plumes of sulfur, giving Io its striking, chaotic palette of brilliant yellows, deep oranges, and stark whites. But what force could possibly power such relentless geological fury? The answer lies not within Io itself, but in the immense gravitational pull of its parent planet, Jupiter, and the persistent tug of war with its neighboring moons. This gravitational stretching and squeezing, known as tidal forces, heats Io's interior like a ball of clay being constantly kneaded. The result is a world with lakes of bubbling lava and a surface that is continually repaved, making it the youngest landscape we know. Strangely, this volcanic chaos is not the only feature-defying explanation. Io is also home to massive mountains, some taller than Mount Everest, yet they were not formed by the tectonic plate movements we see on Earth. Instead, they might be giant blocks of crust, tilting and thrusting upward as the moon's interior constantly melts and churns beneath them. Many scientists now believe that beneath this tormented crust lies a global ocean of magma, a vast, seething sea of liquid rock. Io is not just a moon, it is a glimpse into the raw, untamed power that can shape a world. This relentless volcanic fury is driven by a cosmic engine deep within Io. The immense gravity of Jupiter locks the moon in a perpetual gravitational tug of war. But Jupiter is not acting alone. As Io orbits, its path is perfectly synchronized with the orbits of its sister moons, Europa and Ganymede. For every single orbit Europa completes, Io completes exactly 2. For every one of Ganymede's orbits, Io completes 4. This precise, repeating rhythm is called an orbital resonance, and it prevents Io from settling into a calm, circular path. Instead, the combined gravitational pulls of Jupiter and these other moons constantly stretch and squeeze Io's very structure. Think of repeatedly bending a metal paperclip back and forth in your hands. After just a few bends, the metal at the stress point becomes hot to the touch. Now magnify that effect to a planetary scale. Io is that paperclip being flexed and distorted by gravitational forces so powerful they generate immense internal friction. This friction creates colossal heat, melting Io's rocky interior into a vast global ocean of magma. It is this trapped, seething heat that must escape, and it does so by violently erupting through the moon's thin crust in hundreds of fiery vents. Io is more than a moon, it is a unique laboratory. By studying this extreme process, we gain a key to understanding the powerful dynamics that shape the entire Jovian system and heat other, very different worlds. While Io burns with fire, its neighbor Europa is a world of ice. This moon presents a starkly different mystery, a frozen crust so smooth and bright it looks like a giant cracked marble floating in the void. Its surface is a labyrinth of dark, reddish-brown lines crisscrossing the brilliant white terrain. These are not simple cracks, but vast fractures in an ice shell that is surprisingly young, with very few of the ancient craters that pockmark other worlds. This tells us that Europa's surface is constantly being renewed, erased and repainted by processes from below. The greatest clue, however, is not the cracks themselves, but how Europa interacts with Jupiter's powerful magnetic field. Measurements reveal that Europa creates its own tiny magnetic field in response, one that shifts and changes. The only thing that can explain this behavior is a global, salty, liquid water ocean lying beneath the ice. Scientists are now virtually certain that a hidden sea exists, a body of water so vast it may contain more than twice the liquid found in all of Earth's oceans combined. This transforms Europa from a frozen moon into a water world. The dark, reddish material streaking its surface might be salts and organic compounds welling up from that hidden ocean, deposited on the ice through the very fractures we see. What could be stirring these deep, dark waters, preventing them from freezing solid in the cold of space? The answer is likely the same gravitational forces that torture Io, but here they provide a gentle, persistent heat, flexing Europa's core enough to keep its subterranean sea liquid. This revelation places Europa at the forefront of our search for life. Where there is persistent liquid water, energy, and the complex chemistry we see on its surface, the possibility for life, even in its simplest forms, becomes a question we are desperate to answer. The dark, streaked surface of Europa is a tantalizing canvas, but the real masterpiece lies hidden beneath miles of ice. To find life, we must look down into the profound darkness of a global ocean. Here, in the eternal night of the seafloor, scientists speculate that ecosystems could thrive completely cut off from the sun. The key lies in hydrothermal vents, like those found in the deepest, darkest trenches of Earth's oceans. On our world, these vents are like underwater geysers, spewing mineral-rich, superheated water from the planet's interior. They support stunning oases of life, from towering tube worms to ghostly white crabs, all sustained not by photosynthesis but by chemosynthesis, where microbes convert chemicals into energy. If similar volcanic activity exists on Europa's seafloor, driven by that same gravitational heating that churns its core, then these vents could provide the perfect recipe for life, energy, warmth, and a rich soup of chemicals. The search is no longer a question of if the ocean exists, but what lives within it. This very question is the driving force behind one of the most ambitious space missions ever conceived, NASA Europa Clipper. Scheduled to launch in the coming years, the Clipper spacecraft will not land on Europa. Instead, it will perform dozens of close flybys, using a powerful suite of instruments to act as a remote laboratory. It will map the thickness of the ice shell, analyze the composition of those mysterious surface streaks, and even use radar to peer directly into the icy crust, searching for pockets of water closer to the surface. Its primary goal is to determine if this distant ocean world has the conditions suitable for life. But how do we go from orbiting the moon to actually tasting its waters? The ultimate dream, a mission that still exists on the drawing boards, involves a cryobot, a specialized probe that would melt its way through the icy crust. Imagine a torpedo-shaped device heated from within, slowly descending through the alien ice mile after mile for perhaps years. It would be a journey into utter isolation and immense pressure, a technological challenge unlike any we have ever faced. Finally, it would break through into the open water, releasing an autonomous underwater vehicle to explore the abyss. What would its lights illuminate in the eternal darkness? Would it find strange, drifting organisms, or perhaps only the quiet chemistry of a sterile sea? The answer waits locked in ice at the edge of our solar system. Beyond the frozen shell of Europa lies a giant. Jupiter's moon Ganymede is not merely large, it is the undisputed king of moons, a world so vast it is actually larger than the planet Mercury. If it orbited the Sun on its own, we would classify it as a planet without a second thought. Its surface tells a story of two completely different epochs. Vast, dark, and heavily cratered regions speak of an ancient landscape that has remained unchanged for billions of years, a silent witness to the solar system's violent youth. But these dark plains are sliced through by wide, bright bands of grooved terrain, as if some cosmic claw has raked across the moon's face. These grooves suggest a period of immense geological stress, a time when Ganymede's icy crust was stretched and fractured on a global scale. The greatest mystery of Ganymede, however, is not written on its surface but radiates from its heart. It is the only moon we know of that generates its own magnetic field, a protective bubble much like Earth's. This incredible feature points to a dynamic, churning interior. Scientists believe a molten, convecting core of liquid iron, acting as a colossal dynamo, powers this magnetic shield. But the surprises do not stop there. By studying how this magnetic field interacts with Jupiter's own far more powerful one, researchers have uncovered evidence for another, even more profound secret. Deep beneath the crust, they are convinced there exists a massive subsurface ocean, a layer of salty water trapped between multiple sheets of ice. Picture a celestial club sandwich with layers of different ice types and states stacked upon one another, and tucked within them a vast liquid ocean. This makes Ganymede a world of multiple hidden seas, a place where the conditions for life might exist not just in one ocean, but potentially in several separate layers. How does such a complex world maintain its delicate internal balance, and what strange chemistry might be brewing in its isolated, watery pockets? Ganymede's complex structure gives way to a world of profound stillness. Callisto, the outermost of Jupiter's large moons, is a fossil. Its dark, icy surface is a chaotic jumble of impact craters, one piled upon another in a record of cosmic violence stretching back over 4 billion years. This is one of the most heavily cratered objects we have ever seen, a landscape frozen in time. Unlike its fiery sibling Io or its icy cousin Europa, Callisto shows no sign of volcanoes, shifting ice, or any process that could erase these ancient scars. Its face is a testament to primordial chaos, untouched by the geological forces that renew other worlds. This inert exterior suggests a cold, dead history, a simple ball of rock and ice. Yet our probes have revealed a mystery hidden deep within. Precise measurements of how spacecraft are tugged by Callisto's gravity tell a surprising story. The data implies that this ancient moon is not a uniform solid sphere. Instead, scientists now believe that beneath its battered crust lies a subsurface ocean, a vast layer of liquid water. This is perhaps the most puzzling ocean of all. On Europa and Ganymede, internal heating likely keeps their buried seas in contact with a rocky, mineral-rich seafloor, a potential cradle for life. But Callisto's ocean appears to be completely decoupled, trapped between thick layers of ice and far above any rocky core. It is an isolated abyss, forever separated from the geological energy and nutrients that rock could provide. This presents a fascinating question. Could life ever emerge in such a place, adrift in a dark sea with no volcanic vents and no rocky floor? The chemistry would have to be driven entirely by the slow interaction of water and ice, a subtle and lonely process. Callisto challenges our very definition of a habitable world, proving that potential can hide in the most ancient and silent of places. From the silent fossil of Callisto, we travel to a moon that looks like it belongs in a science fiction epic. Saturn's moon, Mimas, is forever marked by a single, staggering feature, the Herschel crater. This colossal impact basin stretches across nearly a third of the moon's entire diameter, a scar so vast it makes Mimas instantly recognizable as the Death Star moon. You can easily picture the moment of cataclysm, an impact so violent it nearly shattered the entire world to pieces. At the center of this enormous bowl rises a central peak, a mountain of jumbled ice that is almost as tall as Mount Everest on a moon a fraction of Earth's size. For decades, astronomers saw Mimas as the perfect example of a dead world, a simple ball of ice frozen solid for eons, its history written in that one terrible wound. It seemed too small and too inert to hold any further secrets. Then the Cassini spacecraft arrived at Saturn and looked closer. By meticulously tracking the subtle wobbles in Mimas's rotation, a motion known as libration, scientists uncovered a paradox. The way this small moon wobbles does not match what you would expect from a solid, uniform sphere of ice. The data points to two equally startling possibilities. The first is that Mimas might harbor a hidden, elongated ocean of liquid water, sealed deep beneath its battered crust. The second is that it possesses a rocky core that is not spherical but strangely shaped like a football. Both ideas are revolutionary. An ocean would mean that even the most seemingly dead and frozen worlds can hide inner fire and liquid water, the very ingredients for life. A misshapen core would rewrite our understanding of how these moons formed and cooled. This tiny, scarred moon now stands as a giant mystery, forcing us to question everything we thought we knew about what stirs in the hearts of small, icy worlds. The tiny, unassuming moon of Enceladus holds a secret that shatters all our expectations. Orbiting Saturn, this brilliant white world is so reflective it shines like a freshly fallen snowfield. Its surface is remarkably smooth in many places, with vast plains of ice that show few signs of ancient impacts, a clear signal that something is constantly erasing its scars. The epicenter of this activity is a series of deep, parallel gashes near its south pole, features we call the tiger stripes. These are not mere cracks, but warm fractures in the ice, radiating significant heat into the frigid vacuum of space. And from these four great wounds, Enceladus is singing its song to the cosmos. The Cassini spacecraft witnessed the impossible, towering geysers of water vapor and tiny ice grains blasting hundreds of kilometers into the blackness. These are not faint mists, they are colossal, continuous plumes, erupting with such force that they feed one of Saturn's majestic rings. For the first time, we were not just looking at a distant, frozen moon, we were watching it actively spray the contents of its hidden heart directly into space. Cassini did more than just take pictures, it flew right through these plumes, tasting and analyzing their composition. The results were breathtaking. The ice particles were salty, a direct fingerprint of a global subsurface ocean in contact with a rocky core. The plumes also contained a treasure trove of simple organic molecules, the carbon-based building blocks essential for life as we know it. But the final, crucial piece of evidence came from the tiniest of particles, silica nanograins that can only form in very specific conditions when hot water interacts with rock. This was the smoking gun, the definitive sign that on the seafloor of this alien ocean, hydrothermal vents are actively spewing mineral-rich, superheated water into the darkness. On Earth, such vents are bustling oases of life. Enceladus has all three ingredients we believe are necessary for life: liquid water, a source of chemical energy, and the right organic chemistry. This small, icy moon is no longer just a geological wonder. It has become the most promising place beyond Earth to search for living organisms. Saturn's moon Tethys presents a landscape of impossible scale. Imagine a canyon so vast it could span the entire continental United States, a scar that runs for 3/4 of the moon's circumference. This is Ithaca Chasma, a fracture up to 100 kilometers wide and 5 kilometers deep, a gash that would make our own Grand Canyon seem like a mere scratch. The forces required to tear a world apart so dramatically are almost beyond comprehension. Then, on the opposite side of this icy sphere, sits another monumental feature, the Odysseus impact crater. This crater is so enormous, over 400 kilometers across, that its impact did not just create a hole, it fundamentally reshaped the entire moon. The colossal shockwaves from the strike actually flattened Tethys' spherical form, leaving it with a distinctly oval appearance. The central peak of Odysseus itself has relaxed into a wide, smooth plain, a testament to the icy crust slowly flowing over eons to heal the wound. These two titanic features pose a profound, unresolved question for planetary scientists. Are they connected, One compelling theory suggests that the impact that created Odysseus sent seismic waves racing around the tiny world, converging on the exact opposite point with such concentrated force that they literally cracked the moon open, creating Ithaca Chasma in a single catastrophic event. Another possibility is that both features stem from an even older, more violent process, perhaps the freezing and expansion of a vast internal ocean that fractured the crust from within. Tethys stands as a silent monument to a past of incredible violence, its two greatest wounds a permanent record of the chaotic forces that shaped the Saturnian system. Another of Saturn's icy sentinels, Dione, holds a quieter mystery. Its ancient surface is a tapestry of deep, sprawling craters, telling a story billions of years old. Yet, cutting across this primordial landscape are stunning, bright features that once baffled scientists. From a distance, the Cassini spacecraft saw them as delicate, wispy streaks, like scratches across the moon's face. We now know these are not mere discolorations. They are colossal cliffs of ice, some hundreds of meters high, and vast systems of fractures. These brilliant scarps are thought to be pure water ice that has been exposed from within Dione, perhaps from a time when the moon was geologically active. The presence of these dramatic cliffs and canyons suggests a past of immense internal stress and shifting. This led scientists to a profound question. What force could have created such features on a world that seemed so inert? The answer may lie deep beneath the cratered crust. Just as with its smaller neighbor Enceladus, careful analysis of Dione's gravity and its interaction with Saturn points toward a stunning possibility. Dione may possess, or may have once possessed, a liquid subsurface ocean. The evidence is more subtle here, but it is compelling. Even more tantalizing was the faint whisper of activity Cassini detected, a tenuous stream of particles emanating from Dione. This was not the dramatic, plume-filled declaration of Enceladus, but more like a soft, steady sigh, hinting that material might still be slowly escaping from its interior. This transforms our view of Dione from a simple frozen relic into a world with a complex and potentially warm history. Could it still hold a remnant of that buried sea today? And if so, how does its potential for life compare to the vibrant promise of Enceladus? The two moons are a study in contrasts. Enceladus shouts its secrets to the heavens with powerful geysers, offering us a direct sample of its ocean. Dione keeps its mysteries locked in ice, its clues far more subtle and ancient. While Enceladus appears to have all the ingredients for life actively mixing today, Dione's ocean, if it exists, might be a far more isolated and dormant place. It teaches us that habitability is not a simple yes or no, but a spectrum, and that even a world that appears silent on the surface may still hold the faint, warm echo of a once living sea. Represents itself as a twin to Dione, another ancient cratered world orbiting Saturn. Its surface is a record of immense age, a starkly beautiful landscape of gray ice that has endured the relentless bombardment of the solar system's early days. Yet a closer look reveals a subtle but telling difference between its two faces. The hemisphere that constantly leads Re in its orbit around Saturn is brighter and more heavily cratered, while the trailing side is marked by darker, wispy features, much like the brilliant ice cliffs of Dione. This suggests that Re, too, has a story of internal shifts and ancient resurfacing written across its frozen skin. But the greatest puzzle surrounding this moon was one that appeared and then just as mysteriously vanished. During a close flyby, the Cassini spacecraft detected a sudden, sharp drop in electrons trapped within Saturn's powerful magnetic field just as it passed near Re. The data seemed to point to one astonishing conclusion, that Re was the only moon in the solar system surrounded by its own system of rings. The idea was captivating, a small world with its own set of celestial bracelets. Scientists theorized that these rings would be made of fine dust and debris, likely kicked up by eons of meteoroid impacts on Re's surface. This debris would then be held in a delicate disk by the moon's own gravity. Yet when Cassini turned its cameras directly toward Rhe to capture this predicted ring system, it found nothing. Subsequent, more sensitive observations also failed to find any trace of the rings. The initial data, the dramatic drop in electrons, remains a real and recorded event, but its cause is now a complete mystery. What could have created such a pronounced and localized disturbance in Saturn's magnetosphere if not a ring of particles? The answer is still out there, a ghost signal from a moon that dared to possess a secret it may not actually hold. Leaving the stark, icy plains of Rhe behind, we arrive at a world that feels both alien and strangely familiar. Titan is a place unto itself, the only moon in our solar system enveloped in a thick, hazy atmosphere, a deep orange shroud that hid its secrets from our view for centuries. This is not a thin veil, but a dense, nitrogen-rich sky with a surface pressure even higher than Earth's. For the first time, we are looking at a landscape that echoes our own home, but with a chilling, alien twist. Here, carved into the terrain, are river valleys, vast lake beds, and great seas that gleam under the dim sunlight, yet these are not filled with water. On the bone-chilling surface of Titan, where temperatures plunge to -180 degrees Celsius, water is frozen solid, harder than granite. Instead, the rivers flow and the seas ripple with liquid methane and ethane, a form of natural gas that on our world exists as a vapor. This creates a hydrological cycle that is a bizarre, cold mirror of Earth. Methane evaporates from the lakes, forms clouds in the thick atmosphere, and falls back down as rain, carving channels and filling the great basins. But what truly sets Titan apart is the complex chemistry brewing in its orange sky. High above the surface, sunlight breaks apart methane and nitrogen molecules, which then recombine into ever more complex chains of carbon, hydrogen, and nitrogen. These molecules form a kind of organic smog that slowly drifts down to the surface. We call these substances tholins, and they are thought to be the fundamental building blocks for more complex prebiotic chemistry. This thick, tarry sludge rains steadily from the sky, coating the entire moon in a layer of organic material. This constant cosmic drizzle makes Titan a massive laboratory for studying the chemical steps that may have led to life on Earth. The greatest mystery, however, is the methane itself. Sunlight continuously destroys methane in the atmosphere, so for Titan's lakes and rivers to persist over billions of years, there must be a vast reservoir replenishing it from within. This points to a potential cryovolcano, a volcano that spews liquid water and ammonia instead of molten rock, venting fresh methane onto the surface. And this leads to the most profound possibility of all. Beneath the frozen crust and the organic dunes, data from the Cassini spacecraft strongly suggests the existence of a global subsurface ocean of liquid water, much like the one on Europa. This means Titan possesses two completely separate liquid environments, the familiar hydrocarbon seas on the surface and a hidden water ocean in the depths. Could there be life in that dark subsurface sea, sustained by chemistry we can barely imagine? Or perhaps even stranger, could a form of exotic methane-based biology have arisen in the frigid surface lakes, using liquid methane the way life on Earth uses water? Titan is not just one mystery, it is a layered puzzle offering two completely different pathways for life to begin. To truly unlock the secrets of Titan's thick atmosphere and complex chemistry, we need to touch its surface and taste its soil. This is the ambitious goal of NASA Dragonfly mission, a revolutionary rotorcraft designed not just to land but to fly across the alien landscape. Imagine a large drone powered by a nuclear battery, soaring through the hazy orange skies of this distant moon. Titan is the perfect world for flight, with a dense atmosphere that makes lifting easy and low gravity that allows for great leaps. Dragonfly will use this to its advantage, performing a series of hops, each one carrying it tens of kilometers to a new and fascinating location. Its primary destination is the Shangri-La Dune Fields, a vast region of dark, organic sand dunes that sprawl across Titan's equator. These dunes are not made of silicate rock like on Earth, but of frozen water ice grains coated in that complex, tarry organic sludge that rains from the sky. By landing here, Dragonfly will be sampling the most fundamental ingredients of Titan's probiotic chemistry. It will drill into the surface, collect samples, and analyze them right there with its onboard laboratory, searching for the specific types of organic molecules that are the precursors to life. This is not just a geology mission, it is a search for the very recipes that might lead to a living system. Scientists hope to understand how far this chemistry has progressed on its own. Has it created amino acids, the building blocks of proteins, or even more complex structures like nucleotides, the pieces of genetic code? Dragonfly will not look for life itself, but for the evidence that Titan's environment is capable of creating the pieces from which life could assemble. By hopping from the dunes to the floor of an ancient impact crater, it will investigate a place where liquid water may have once mixed with the surface organics, creating a potent brew for even more complex chemistry. This mission will transform Titan from a distant, hazy orb into a world we can explore firsthand, giving us our first real understanding of how life's ingredients are forged in the cosmic kitchen. The stark chemical landscape of Titan gives way to a moon of pure cosmic contrast. Orbiting Saturn at a great distance is Iapetus, a world divided against itself. One half of this moon is as dark as fresh asphalt, a terrain coated in a mysterious reddish-black material. The other half gleams with the brilliant whiteness of freshly fallen snow. This is not a subtle gradient but a sharp, dramatic split along its equator, creating a celestial yin and yang. The leading hemisphere, the face that plows forward as Iapetus moves along its orbit, is the dark side. The trailing hemisphere is the bright one. For centuries, astronomers struggled to explain this two-faced nature. The leading theory points an accusing finger at another, more distant moon of Saturn, the dark and irregularly shaped Phoebe. Phoebe is constantly bombarded by tiny meteoroids, kicking up a fine, dark dust. This dust slowly spirals inward toward Saturn, and Iapetus, like a giant windshield on a cosmic highway, collects this debris on its leading face. The dark material does not just sit there, it actively transforms the landscape. Because the dark areas absorb more sunlight, they grow warmer. This warmth causes any exposed water ice on the surface to sublimate, turning directly from a solid into a gas. This gas then drifts across the moon and refreezes onto the colder, brighter regions, further intensifying the contrast in a self-reinforcing cycle. The dark gets darker and warmer, the bright gets brighter and colder. But this is not the only grand mystery Iapetus holds. Stretching perfectly along its equator is a mountain range of impossible proportions. This is the equatorial ridge, a wall of ice and rock that soars up to 20 kilometers high and runs for over 1,300 kilometers, circling the moon like the seam on a giant walnut. How did such a perfect, continuous feature form? One compelling idea is that Iapetus once spun much faster than it does today, and as it cooled, its crust contracted and thickened, squeezing material upward at the equator like a tube of toothpaste. Another, even more dramatic theory suggests the ridge is the fossilized remains of a ring system that once belonged to Iapetus itself. In this scenario, debris from a massive ancient impact circled the moon, only to slowly rain down and pile up along the equator, building the ridge grain by grain over eons. Iapetus challenges us with two profound and seemingly unrelated puzzles, a moon of two colors and a single, perfect ridge, leaving us to wonder if their origins are separate or part of one incredible, lost chapter in the history of the solar system. Its jigsaw puzzle landscape defies all logic, a world that looks as if it was shattered by a cosmic hammer and then glued back together by a careless giant. This is Miranda, the innermost and most bizarre of Uranus's major moons. Its surface is a chaotic patchwork of wildly different terrains, where ancient, heavily cratered plains lie abruptly beside much younger, grooved regions, all stitched together with jagged seams. The transitions are not gradual, they are violent and immediate, suggesting a history of unbelievable turmoil. The most stunning features are its three enormous coronae, regions named Arden, Elsinore, and Inverness. These are not simple craters or plains, but vast, ovoid, crown-like structures, each one a unique geological masterpiece. They are marked by concentric patterns of ridges and troughs, resembling giant racetracks etched into the ice. Bordering these coronae are some of the most staggering cliffs in the solar system. Verona Rupes is a fault scarp, a sheer cliff face that soars to a height of over 20 kilometers. That makes it 12 times deeper than the Grand Canyon, a vertiginous drop into an abyss of shadow. How did such a small moon, only about 470 kilometers across, come to possess such extreme and varied landscapes? The leading theory is one of absolute cosmic violence. Scientists suspect that Miranda was once completely shattered in a cataclysmic collision, broken into countless pieces. Over time, its own gravity pulled these fragments back together, but the reassembly was haphazard and chaotic, creating the jumbled patchwork we see today. Another compelling idea points to the Moon's eccentric orbit, which would have subjected it to intense and changing tidal forces from Uranus. This gravitational stretching and squeezing could have generated enough internal heat to cause massive overturning of its interior, with warmer ice rising to the surface in colossal, sluggish plumes, distorting the crust and creating the coronae. Perhaps both events occurred, a shattering impact followed by a slow, tortured rebirth. Miranda stands as a frozen monument to survival, a world that endured utter destruction and was remade into one of the strangest objects we have ever seen. Ariel shines as the brightest jewel in Uranus's collection of moons, but its gleam reveals a world of profound and frozen conflict. Its surface is a breathtaking tapestry woven from two opposing forces, one of violent rupture and the other of gentle repair. Vast networks of enormous canyons and fault valleys slice across the landscape, some stretching for hundreds of kilometers and plunging deep into the icy crust. These are the scars of a world that was once being torn apart from within. Yet, lying between these dramatic chasms are surprisingly smooth, flat plains, regions that appear much younger than the fractured highlands. These plains are not cratered and ancient, they have been resurfaced, as if a fresh layer of icy material once welled up from below and flooded the tortured terrain, smoothing over the wounds. The story written on Ariel is one of a dramatic, active past. Scientists believe this activity was fueled by tidal heating, the same gravitational flexing that powers the volcanoes of Io, though here it was likely gentler. This internal warmth would have been enough to partially melt a subsurface ocean or soft ice layer. This slushy material then erupted onto the surface in a process called cryovolcanism, where water, possibly mixed with ammonia as a kind of cosmic antifreeze, flowed like lava across the landscape, creating those smooth plains. The great mystery of Ariel is not what happened, but why it stopped. This moon is now a frozen snapshot of its dynamic past, a world that was once alive with geological activity but has since fallen silent. What caused the internal heat to fade? Did its orbit around Uranus stabilize, ending the gravitational tug of war that kept its interior warm? Or did it simply cool and solidify, locking its remaining ocean away forever beneath a thick, unyielding shell of ice? Ariel presents us with a ghost of a world that was, a beautiful and intricate monument to a time when ice could flow and canyons were born. While Ariel gleams with the memory of a dynamic past, its companion Umbriel is a world cloaked in permanent shadow. This moon is the darkest of Uranus's major satellites, a stark, uniformly gray sphere that seems to absorb the faint sunlight. Its surface is a sea of ancient craters, one overlapping another in a record of impacts that stretches back to the very dawn of the solar system. There are no vast canyons, no smooth resurfaced plains, no signs of the internal turmoil that reshaped its neighbors. Umbriel is profoundly inert, a frozen time capsule that has remained virtually unchanged for billions of years. Yet, on this canvas of darkness, there is one brilliant and perplexing anomaly. Within the enormous Wonder crater, a feature over 100 kilometers wide, lies a perfect gleaming ring of material. It sits on the crater floor, a bright, circular crown whose composition remains a complete mystery. Is it a deposit of fresh, pure water ice that was exposed from deep below by the impact? Or is it a strange type of salt or frozen ammonia that contrasts sharply with the dark, carbon-rich material covering the rest of the moon? No one knows for sure. This single, luminous ring on an otherwise dead world makes Umbriel's silence even more profound. Why did this moon remain so cold and dormant while Ariel and Miranda were being torn apart and remade? The answer likely lies in its orbit and internal structure. Umbriel may have always been just a little too far from Uranus, or its core a little too cold, to experience the significant tidal heating that stirred its siblings. Without that internal engine to drive geological change, Umbriel simply endured, collecting cosmic dust and the scars of impacts, its surface darkening over eons into the featureless, ancient landscape we see today. It is the solar system's perfect archive, a world that chose to preserve its primordial scars rather than erase them. The darkness of Umbriel gives way to a world with a far more dramatic story carved into its icy skin. Titania, the largest moon of Uranus, is a world of giants. Its surface is a complex mosaic of immense impact craters and vast, smooth plains, a clear sign that geological forces have been at work here, erasing ancient scars and rewriting the landscape. But the most breathtaking features are the colossal canyons that slash across the terrain, dwarfing anything found on Earth. The greatest of these is the Messina Chasmata, a canyon system that runs for over 1,500 kilometers, a gash so long it could stretch from New York City to the heart of Florida. Its steep walls plunge for kilometers into the darkness, a testament to forces that gripped this moon in its distant past. How does a frozen world in the outer solar system tear itself apart so dramatically? The leading theory points to a profound transformation deep within Titania's heart. Scientists speculate that this moon may have once possessed a subsurface ocean, a layer of liquid water sandwiched between its rocky core and its icy outer shell. As this internal sea slowly cooled and began to freeze, the water would have expanded. Ice, unlike most substances, takes up more space as a solid than as a liquid. This expansion from within would have placed the entire moon under immense global tension, stretching its brittle crust until it fractured on a planetary scale. The Messina Chasmata is likely the result of this global cracking, a monumental scar from a time when Titania's heart was turning to ice. This presents a compelling mystery. Was Titania ever warm and active enough to maintain a liquid ocean? The presence of those smooth, resurfaced plains suggests that not only water, but also a kind of slushy ice or even ammonia-rich antifreeze might have welled up from below to flood the lowlands, much like lava flows on Earth. If so, Titania was once a dynamic world, with a churning interior possibly heated by the same gravitational forces that shaped its siblings. Today, it is almost certainly frozen solid, a silent giant. Yet, by studying its structure, the depth of its canyons, and the extent of its resurfacing, we can peer back in time. Titania holds crucial clues about the life cycle of mid-sized icy moons, helping us understand how common these hidden oceans might be, and how long they can persist before the cold of deep space finally wins, locking their secrets away forever. The outermost sentinel of Uranus's major moons, Oberon, completes this family of frozen worlds with an air of ancient and brooding silence. Its surface is a stark portrait of endurance, an old, dark, and deeply cratered landscape that mirrors the profound stillness of Umbriel. Here, the scars of countless impacts have accumulated over billions of years, painting a picture of a world that has known only cosmic violence and deep freeze. Yet, nestled within this seemingly inert facade are two profound mysteries that refuse to let us write Oberon off as a simple relic. The first is a strange, dark material that coats the floors of many of its craters. This is not the uniform gray of Umbriel, but something more targeted and specific, as if a tarry substance has welled up from below to pool in these low-lying basins. The second enigma is even more striking, a lone, massive mountain peak that juts abruptly from the surface, a singular spire casting a long shadow across the cratered plains. What could cause a single mountain to rise in such isolation on a world otherwise defined by random impacts? The dark material offers a tantalizing clue. One leading theory suggests that this substance was not deposited from above, but erupted from within. This points to a past era of cryovolcanism, where a slushy mix of water, ammonia, or methane might have oozed from fractures in the crust, painting the crater floors with a layer of dark, organic, rich sludge. If true, this means Oberon was not always the frozen tomb it appears to be today. It may have once harbored enough internal warmth to drive geological activity, briefly stirring to life before its internal fires faded forever. That solitary mountain could be a remnant of that more dynamic time, a cryovolcanic dome that never fully collapsed, or a block of crust thrust upward by internal stresses we can now only guess at. Oberon challenges us to look beyond a battered surface, forcing us to ask how many other seemingly dead worlds are secretly holding the ghost of a warmer, more active past. Far beyond the silent giants of Uranus lies a world that should not exist where it is. Neptune's moon Triton moves in absolute defiance, orbiting its planet in the wrong direction, a retrograde path that marks it as a cosmic intruder. This moon was not born alongside Neptune. It is almost certainly a captured citizen of the Kuiper belt, a vast realm of icy bodies beyond Neptune's orbit, gravitationally snared by the giant planet in the solar system's violent youth. This foreign origin explains its bizarre and active surface, a landscape that defies the deep freeze of its location. Triton is one of the few geologically active worlds in the outer solar system, and its cryovolcanism is unlike any other. Across its frozen nitrogen plains, great dark geysers erupt, blasting plumes of nitrogen gas and dark dust particles kilometers up into its incredibly thin atmosphere. These plumes create dark streaks across the bright ice, staining the surface for miles. What could possibly power these eruptions so far from the sun's warmth? The answer may lie in a greenhouse effect trapped under Triton's clear ice. Sunlight penetrates the transparent surface ice, heating a layer of dark, trapped nitrogen gas beneath. The pressure builds and builds until the ice cracks and the nitrogen erupts in a violent, explosive venting. But the geysers are only part of the mystery. Much of Triton's surface is covered in an astounding feature known as cantaloupe terrain, a vast region of dimpled, intersecting ridges and depressions that looks exactly like the skin of the fruit. This strange landscape is thought to be the result of the slow, churning overturn of Triton's icy crust over eons. Yet the greatest secret of this captured world may be hidden deep below this chaotic skin. Triton's unusual orbit, even after its capture, is not perfectly circular. This means it still experiences subtle gravitational tugs from Neptune, a flexing that generates internal tidal heat. This heat, a relic of its dramatic capture, might be enough to maintain a global subsurface ocean of liquid water, sandwiched between its icy shell and a rocky core. That makes Triton, a wanderer from the distant Kuiper belt, another unexpected candidate in our search for habitable environments. A world born in the frozen depths, captured by a giant, and kept warm by the same forces that imprisoned it, could now be sheltering a hidden sea in the perpetual darkness. Nereid's path around Neptune is a wild, looping dance unlike any other. This small moon follows the most eccentric orbit we have ever recorded, a stretched and lopsided ellipse that carries it on a dramatic journey. At its closest approach, it swings near its planet, only to be flung out to an immense distance over 9 times farther away. This is not the gentle, predictable orbit of a moon born in peaceful circumstances. Such an extreme path is a clear signature of a violent past, a gravitational scar. The most likely culprit for this chaos is the arrival of Triton itself. When Neptune captured the massive Triton, the event would have been catastrophic for any original family of moons. The gravitational upheaval would have been like a wrecking ball swinging through a calm solar system, scattering smaller bodies, tearing them from their old orbits, and hurling them into new, erratic paths. Nereid is a surviving witness to that ancient cataclysm. Its wild orbit is not random. It is a fossilized record of that moment of capture, a permanent mark of the chaos that reshaped Neptune's celestial neighborhood. This tiny moon, often overlooked, is therefore a crucial piece of evidence. By studying its precise path, we can work backwards, piecing together the forces at play during one of the solar system's most dramatic events. Nereid is a living relic, a testament to the fact that even the most stable-looking planetary systems can have a hidden history of incredible violence. The drama of captured moons gives way to a celestial dance of equals at the very edge of our known system. Pluto and its largest companion Charon are locked in a gravitational embrace so intimate that they orbit a point in the empty space between them. This is not a planet with a simple satellite, but a binary dwarf planet system, a double world waltzing in the frozen dark. Charon itself is a surprisingly complex and active place, a world that defies its small size. Its most striking feature is a colossal canyon system that snakes across its face, with one chasm, the Serenity Chasma, stretching for over 1,600 kilometers and plunging to depths of several miles. This is a fracture of almost unimaginable scale, but the true enigma lies at Charon's pole, a great dark stain officially named Mordor Macula. This sprawling, reddish-black cap is a stark contrast to the moon's otherwise pale water-ice landscape. The leading theory for its origin is a cosmic theft. Pluto, even in its frozen state, has a tenuous atmosphere that slowly leaks nitrogen and methane into space. These gases, exposed to solar radiation, are processed into complex, dark organic compounds called tholins, the same reddish gunk that rains on Titan. Some of this material, it is thought, drifts across the void and is captured by Charon's gravity. But why does it collect only at the pole? The answer is a deep, cold trap. Charon's polar regions are so perpetually frigid, plunged into darkness for decades at a time, that any tholin particles settling there become permanently frozen in place, unable to escape and slowly building up over millions of years into that ominous dark hood. Yet the canyons point to an even more dynamic history. The massive tectonic fractures scarring Charon's surface are evidence of a global upheaval. Scientists believe this moon may have once harbored a subsurface ocean, kept liquid by heat from the radioactive decay of its rocky core and the fierce gravitational tug of war with Pluto in their youth. When that interior eventually froze, the water expanded as it turned to ice. This expansion would have stretched Charon's crust to its breaking point, cracking it open on a global scale and creating the vast chasms we see today. Charon is a world of profound contradictions, a place marked by both stolen colors from its partner and the deep, internal scars of its own frozen heart. Beyond the intimate dance of Pluto and Charon lies a system of chaos. Orbiting this binary pair are 4 smaller moons, and 2 of them, Hydra and Nyx, are spinning out of control. These are not neat, spherical worlds, but irregular lumps of rock and ice, shaped more like potatoes than planets, and they do not rotate with the calm predictability of Earth's moon. Instead, they tumble through space in a state of complete rotational chaos, their poles and equators swapping places unpredictably. If you stood on the surface of Nix, you would not experience a regular day and night cycle. The sun would whirl madly across the sky, rising and setting in random directions, with days and nights of wildly varying lengths. This bizarre behavior is a direct result of the complex gravitational environment they call home. They are not orbiting a single, central point, but the constantly shifting center of mass between Pluto and Charon. The relentless, uneven gravitational tugs from these two larger bodies act like a series of random pushes, preventing the small moons from settling into a stable spin. This chaotic dance provides a fascinating glimpse into the fundamental dynamics that govern small bodies in complex systems across the cosmos. Yet their tumbling is not the only puzzle. Hydra and Nix are astonishingly bright, reflecting light with the brilliant intensity of freshly fallen snow. This suggests surfaces composed of almost pure water ice, a surprising discovery so far from the Sun. How did they retain this pristine ice coating over billions of years? The answer may lie in their size. They are too small to hold onto any atmosphere, and without atmospheric chemistry or geological activity to darken their surfaces, they remain frozen time capsules, their bright ice exposed to the void. These tumbling, brilliant moons are more than just orbital curiosities. They are natural laboratories showing us how gravity shapes the smallest members of a planetary system and preserving a record of the primordial ices from which the entire Pluto system formed. Saturn's moon Hyperion looks like nothing else in the solar system, a celestial sponge frozen in time. Its surface is a chaotic jumble of deep, dark craters with razor-sharp edges, giving it a porous, pitted appearance that seems almost unnatural. But this bizarre form is only the beginning of its strangeness. Hyperion is a cosmic tumbler, rotating with such unpredictable chaos that you could never set a clock by its day. It does not spin on a steady axis like Earth or even our own moon. Instead, it wobbles and flips so erratically that its exact orientation in space is fundamentally unknowable more than a few weeks into the future. This chaotic dance is a direct result of its irregular shape and the competing gravitational tugs from Saturn and its massive moon Triton. It is a world without a predictable sunrise, a place of true orbital anarchy. This tumbling is not its only lightweight quality. Hyperion has an incredibly low density, so low that it must be mostly empty space inside. Scientists believe it is a rubble pile moon, a loose collection of ice and rock held together by gravity, with vast caverns and voids making up much of its volume. If you could stand on its surface, you might hear the echoes of impacts reverberating through its hollow interior. The deep craters themselves hold another secret, their floors coated in a layer of dark, reddish gunk. Analysis suggests this material is rich in hydrocarbons, the long, complex chains of carbon and hydrogen that are the fundamental building blocks for more complex chemistry. Unlike the active worlds of Enceladus or Europa, Hyperion shows no signs of internal heat or geological renewal. It is a pristine relic, a piece of the early solar system that was never melted or transformed. It represents a different kind of mystery, not one of hidden oceans or potential life, but of pure, unprocessed preservation. This strange, spongy world is a frozen archive, asking us what secrets about our system's raw ingredients have been locked in its fragile, tumbling frame for billions of years. That dark material staining Iapetus had to come from somewhere, and its origin points directly to one of Saturn's most enigmatic outer moons. Phoebe is a world of shadows, a roughly spherical but heavily battered moon that moves to the beat of its own drum, orbiting Saturn in the opposite direction of nearly all its neighbors. This retrograde path is our first major clue that Phoebe is a stranger here, an immigrant from the distant reaches of our solar system. Its surface is incredibly dark, reflecting only about 6% of the sunlight that hits it, making it nearly as black as charcoal. This darkness, however, is not a uniform blankness. The Cassini spacecraft revealed a landscape of stunning complexity. scarred by immense craters and sculpted by dramatic variations in brightness. Deep, light-colored ice is exposed on the steep walls of craters and on other fresh surfaces, suggesting that Phoebe is coated in a thin blanket of dark material over a much brighter, icy interior. This layered structure tells a story of a dramatic past. Phoebe shows clear signs of having been differentiated. This means it was once warm enough, early in its history, to melt completely, allowing heavier rocky material to sink and form a dense core, while lighter icy material rose to form a mantle. For a relatively small object like Phoebe to have experienced such profound internal heat, it must have formed with radioactive elements that have since decayed, or it may have been heated by the immense energy of its own formation. This warmth means Phoebe was once an active, evolving world, not just a simple lump of ice and rock. All of this evidence points to a single, extraordinary conclusion. Phoebe is almost certainly a captured centaur. Centaurs are small, icy bodies that originate in the Kuiper belt beyond Neptune, but now orbit the Sun in the tumultuous region between Jupiter and Neptune. Phoebe was one of these nomadic wanderers until a fateful gravitational encounter with the young Saturn pulled it into its current, backward orbit. This foreign origin explains its composition, its darkness, and its defiant path. But Phoebe's influence extends far beyond its own cratered surface. It is the suspected source of that mysterious dark dust that coats the leading face of Iapetus. Micrometeoroids constantly pelt Phoebe, kicking up its dark surface material. This dust then slowly spirals inward toward Saturn, and Iapetus, on its stately progress, simply collects it like a car's windshield collecting bugs on a highway. Even more remarkably, this process has created one of the largest known features in the entire solar system, a colossal, tenuous disk of fine dust particles orbiting Saturn in the same retrograde direction as Phoebe itself. This is the Phoebe ring, a vast, faint halo discovered by NASA's Spitzer Space Telescope. It is so enormous that it would take roughly 1 billion Earths lined up side by side to span its diameter. Phoebe is not just a moon, it is a painter and a ring builder, a captured relic from the solar system's outer darkness that has left its mark across the entire Saturnian system. The faint reddish glow of Amalthea is a ghost light in Jupiter's shadow. This tiny inner moon is a world shaped not by its own geology, but by the overpowering presence of its planet. It is a lopsided, potato-shaped lump of rock and ice, scarred and ancient. Its most striking feature is its deep red color, a hue that makes it stand out against the pale or orange tones of its larger siblings. This is not a natural pigment but a cosmic stain. Amalthea orbits deep within Jupiter's ferocious radiation belts, a zone of intense atomic punishment. For billions of years, high-energy particles have relentlessly pounded its surface, slowly altering the chemistry of the minerals there and baking them into that distinctive, rusty color. It is a moon being continuously painted by the violent environment it calls home. Yet the greater mystery lies not on its surface but within. When scientists measured Amalthea's gravitational influence, they discovered something astonishing. Its density is incredibly low, so low that it cannot be a solid chunk of rock. The numbers suggest that Amalthea is mostly empty space, a loose collection of boulders, ice, and dust barely held together by its own meager gravity. We call this a rubble pile moon. If you could somehow pick it up and shake it, you might hear the rubble shifting inside its fragile shell. This fragile nature raises a profound question. How could such a delicate structure survive in such a violent gravitational neighborhood? The constant radiation bombardment may hold a clue to its past. All that energy slamming into its surface might have generated enough heat to warm its interior for a time, perhaps even helping to soften and rearrange the rubble, allowing it to settle into the loosely packed structure we detect today. Amalthea is a testament to fragility, a world that should have been torn apart by the forces around it, yet it endures as a porous, red-stained sentinel orbiting within the storm of its king. Jupiter's immense gravity commands a vast and chaotic family far beyond its 4 famous Galilean moons, orbiting at a great distance in a realm of faint sunlight and retrograde paths are the captured wanderers known as the irregular moons. 2 of their most prominent leaders are Hymelia and Calm, celestial chieftains of their own distinct tribes. Hymelia is the giant of the non-Galilean moons, a dark, lumpy world that presides over the Hymelia group, a collection of smaller moons all traveling in similar, tilted orbits around the giant planet. This is not a random arrangement. The shared path is a powerful clue that these moons are not individual captives, but the dispersed remains of a single, larger parent body, shattered long ago in a colossal collision. Hymelia is the largest surviving fragment, the patriarch of its own celestial clan. Even farther out, moving in the opposite direction of Jupiter's rotation, is the moon Calm. It is the namesake and largest member of the Calm group, a tight-knit family of over 20 moons all locked into nearly identical retrograde orbits. This perfect orbital synchronicity is the most compelling evidence we have. It tells a story of a single captured asteroid, perhaps dozens of kilometers across, that wandered too close to Jupiter's gravitational domain billions of years ago. This primordial interloper was then torn apart, either by a catastrophic impact with another object or by the immense tidal stresses of Jupiter itself. The debris from that ancient breakup, held captive by the planet's gravity, slowly coalesced into the swarm of moons we see today, with Calm as their largest remnant. The profound mystery these moons present is not about hidden oceans or geological activity, but about our own solar system's origin story. Hymelia, Calm, and the dozens of other irregular moons are almost certainly captured asteroids or comets from the outer solar system. They are cosmic fossils, pristine samples of the material that was swirling around in the early days of planetary formation. By studying their composition, we are effectively performing an archaeological dig on the building blocks of the giant planets. Their dark, reddish surfaces are thought to be rich in complex organic compounds, the same kind of primordial ingredients that were delivered to the early Earth by comets and asteroids. These captured moons are a frozen library, holding records of the chemical and physical conditions in the solar system's distant past. They represent the raw, unprocessed material from which Jupiter and its siblings first began to grow, offering us a direct glimpse into the chaotic construction site our cosmic neighborhood once was. From the faint, captured wanderers of Jupiter to the erupting geysers of Enceladus, these 25 worlds present a catalogue of cosmic wonders. We have journeyed past volcanic hellscapes, sailed over hidden alien seas, and stood before cliffs that dwarf our greatest mountains. Each moon is a unique chapter in the grand story of our solar system, a testament to the incredible diversity that emerges from simple laws of physics and chemistry. Some, like Io, show us the raw, untamed power of gravity. Others, like Europa and Triton, offer the tantalizing possibility of life in forms we are only beginning to imagine. There are silent fossils like Callisto, chaotic survivors like Miranda, and captured nomads like Triton, each preserving a different piece of our cosmic history. They are not just rocks and balls of ice, they are dynamic worlds with their own personalities, their own dramas, and their own profound secrets. This grand tour is only the beginning. In the coming years, missions like Europa, Clipper, and Dragonfly will travel to these distant spheres, turning our questions into answers and our mysteries into new, even deeper enigmas. They will taste the plumes of Enceladus and fly through the hazy skies of Triton, bringing us closer than ever to understanding our place in the universe. So we turn the question to you, with all these incredible worlds now in your mind, which one captures your imagination the most? Is it the fiery moon, the frozen ocean world, or the captured wanderer? Let us know in the comments below and subscribe to join us on our next journey into the cosmos.